hopefully our platinum is still in solution here. Let's have a look. Zoom in a little bit. Good focus. All right. Oh yeah. Oh yeah. The platinum is still there. All right, good. Looks much more concentrated than it was. Well, hello scrappers, Mike here. Welcome back to my channel and welcome to part 3, believe it or not, part 3 of me trying to recover the platinum from Johnny's mystery electronic components, although they are no longer really a mystery. Figured out in part 2 that they are selenium rectifiers, which explained a lot. All the trouble I was having isolating the platinum from these things is because the selenium got in the way. Now, one mystery that still stands is why there's platinum in them in the first place. I don't get it. Selenium rectifiers don't normally contain platinum. There's no reason for it to be there. And I've actually taken apart one of them and looked inside, thinking, well, maybe there's a resistor in there that uses some platinum group metals in it or something, but no. It's just a stack of metal plates, a selenium rectifier. There should not be any platinum group metals in there, but there are. I'll throw in a couple of pictures of what the thing looks like. Okay, so back in part 1, crushed a bunch of them up, floated the plastic off, and started hitting it with acid. Had some trouble with both the acid dissolving the metal, causing boilovers, and also had trouble with filtration. The selenium, the amorphous selenium I was getting out of these things was clogging my filters and preventing me from being able to filter the liquid I took off. Okay. Part 2, I finally managed to get rid of the bulk of the selenium once I knew it was selenium, because I didn't know that until part 2. Figured out a way to treat it with concentrated nitric acid to make selenous acid, which stays in solution, and get rid of all that selenium sludge that I was dealing with and get down to a black powder, which is at least partly platinum. Why, I don't know, but it is. It's platinum. So I've got some aqua regia over here that has platinum in it. It shows a nice positive for platinum with a stannous chloride test. This is what I did in part 2. And this liquid over here is from my small-scale 100-gram test I did, where I discovered initially that there is platinum in these things. And then, of course, I've got these filters from all the multiple filtrations I did. There's a lot of them here. And they are just loaded with selenium. So I don't quite know what to do with these. Have some ideas, but I'm not sure it's even worth the effort. Because I suspect out of that 2.5 kilos of stuff Johnny sent me, I would suspect that better than 50% of the platinum is right here in these 3 containers. Whatever's in these filters is probably really fine and probably just a fraction of the total. I would say well below 50%. Because all of every time I took liquid off, I siphoned it off rather than decanting it. So I don't think I poured any heavies out of the bottom of the beakers. I was really careful to leave heavies in the bottom of the beaker. So I don't think there's that much in the filters. And processing them is going to be very, very, very difficult and could possibly produce some highly toxic compounds like selenium dioxide. So I'm just going to leave that alone for now. What I would like to do is determine how much platinum I got out of that roughly 2.5 kilos of stuff from Johnny in the form of powder here that's not in the filters. Because I'll know whatever I have here, there's at the most, a little bit more here. And I'll tell you what, right off, this does not look like very much platinum. Okay? Um, at the end of part 2, I put some aqua regia on this stuff, and only a fraction of it dissolved. But platinum doesn't really like to dissolve in aqua regia that well, so I'm not really surprised. So there's still an awful lot of fine black powder in this beaker that did not dissolve. Now in my small scale test, I actually got it all to dissolve, but I wasn't really in any hurry. So I was kind of rushing at the end of part 2 to try and get, a stannous chloride test positive for platinum. So I just don't think I got very much platinum dissolved out of this at all. Most of this stuff here, there's still a whole lot of black powder in this beaker. So I think what I need to do is I need to treat this with some more aqua regia and see how much of it I can get into solution. And then we'll combine all 3 solutions and see if we can drop the platinum out of it and see if we can get a weight on it. I mean, I can already tell the yield's going to be low, but I'd like to know an exact number. It's really hard to know here since I can't. I mean, I could dry this stuff out and weigh it, but there's a lot of debris in there too. So, I'm just not going to be comfortable with whatever yield I get, even if it's very small. So I think what we need to do is just try and clean this up a little bit first, because there is a lot of debris in there, and then hit it with some more aqua regia. See if I can get as much of this, what I assume is platinum, in here into solution as I can, and then we'll drop the platinum back out of solution and see if we can get a weight on it. So that's the plan for this video. What's the first step? Well, I think the first step is I want to try and clean this stuff up. There is a lot of, I don't know, nastiness in here with this platinum. I don't know what it is. It looks like plastic. It's fairly dense, though, because it hangs out down with the platinum, but it certainly looks like plastic. So I think what I want to do is dehydrate this. I'll just evaporate off the little bit of water left in here. And then what I'll probably do is treat this with some hot concentrated sulfuric acid, see if we can digest that plastic and just get rid of it. Turn it into fine fluffy carbon, which I can rinse out of the beaker, and then we should have fairly clean platinum down there that we can try dissolving in aqua regia again. And then we'll try and figure out some sort of yield, knowing, of course, that some of it's going to be in the filters, but probably not that much. So let me do that. Let me get this in the fume hood on some low heat. We'll get it evaporated. We'll put some sulfuric acid on it and crank the heat up and see what that does. Hopefully it will digest all this debris down here, and then we can we'll have some clean platinum to go to aqua regia with. Okay, so let me turn the heat on this stuff, and we'll evaporate off that little bit of water left in there and go from there. Now, I know somebody in the comments is going to suggest this, so I'll address it right now. Somebody in the comments is going to say, well, instead of concentrated sulfuric acid, why don't you just mix yourself up some piranha solution and try that instead? Well, piranha solution scares me, to be perfectly honest. I don't really want to mess with it. And I think the concentrated sulfuric acid will work good enough with some heat applied to it. I don't think we need to go to the extreme of piranha solution unless the concentrated sulfuric acid doesn't work. Then maybe I'll try it, because I would really like to get this goopy, gummy debris out of here, whatever it is. I'll tell you what, this process has been so rough on my glassware, you have no idea what I've had to go through to try and clean it up. I've boiled this one a couple of times in ammonia, and it's just starting to get cleaner. Ammonia is the only thing I found that will take off that scum on the inside. And then this one here is getting pretty grungy too. One other thing I want to mention about part 2 before we go on is I figured out why my nitric acid extractions did not do a good job of getting rid of the base metals in the beakers. The nitric acid was attacking the selenium as well as the base metals. In fact, the selenium is more reactive than some of the base metals. So that's why I kept putting acid on it. I kept putting nitric acid. I kept putting poor man's nitric on it, and I used a lot of nitric acid trying to dissolve that base metal, much more than it should have taken to do it. And the reason, I'm pretty sure, was the nitric acid was reacting with the selenium to make selenous acid. So that's why my nitric acid extractions really sucked on that large quantity of material. When I did my small scale test, it worked great, but there wasn't that much material, and I digested the selenium and the copper and all the other base metals in there. But on the large scale, it just didn't work that good. Okay, we're going to let this warm up and evaporate, and then we'll hit it with some concentrated sulfuric acid to see what happens. Well, this stuff's all dried up now. Nice dry powder in there. Let's get it in the fume hood, get on some heat, some serious heat, with some concentrated sulfuric acid on it, and see if we can pyrolyze whatever that plasticky looking stuff in there is into fine carbon, which I can then get rid of. Alright, we're back on the hot plate. I've got a different brand of sulfuric acid than I normally buy here, but this was what was in the store, so we'll give it a try. Virgin sulfuric acid. Doesn't really say what its concentration is, but usually this stuff is in the high 90s. So I'm not going to put too much on because I know I'm just going to have to use a lot of water to neutralize it later. And okay, oh yeah, look at that. It went from pink to black already, so it's doing something. I put some serious heat to it, get the fume hood going, because I got a feeling we're going to be making some nasty fumes pretty quick. And we'll just let this heat up and see what happens. Well, it's been maybe 5 or maybe closer to 10 minutes, and we're starting to get some bubbling in there. So something's happening. I know we're not hot enough to boil that sulfuric acid yet, but we're probably hot enough to start dehydrating that debris in there, whatever it is. That organic stuff is getting pyrolyzed. Oh yeah, a pretty good bubbling going on now and then. So I've cranked this pretty much up to the max, and yeah, there's something going on in there. Good. Okay, it's been a few more minutes. We're starting to get some smoke coming off and some serious bubbling in there. So this is much like the process of wet ashing IC chips and gold corner VGA chips, but with a lot less organic material in there. So this probably isn't going to take too long, and I don't have to worry about a big boil over, I don't believe, because there's not enough organic matter in there to really cause us to have a boil over. And that organic matter should be getting converted to carbon, which is probably why the acid has gotten so darn black. So this is exactly what I wanted to see happen. I'm going to let it go for a little while longer and then turn it off, because I think we're probably getting hot enough to start vaporizing some of the acid. We don't need to be that hot. Okay, this stuff's had a chance to cool off. So now what I want to do is dilute that acid, and we're going to observe chemical best practices here, and we're going to pour the acid into water, not the other way around. Still slightly warm, but not too bad. Let me just get it all in there. Everything. We'll see what's left on the bottom of this big beaker when I decant off the acid. A few things stuck to the inside. Okay. Okay, so, oh yeah, that got good and warm. Putting the acid into even 1,000 milliliters of water, it got good and warm. All right, so I'm going to decant this off into another container, and we'll see what's on the bottom. The platinum should have sunk to the bottom, and we should be able to get a good look at it once I decant this liquid off, which is now a lot less dense than it was. Sulfuric acid is quite dense, but now it's mostly water. So I'm not too worried about platinum staying in the liquid column. It's going to be on the bottom of the beaker. Let me find a container big enough to dump all this stuff off into, and we'll see what's left on the bottom of it. Alrighty, let's get some aqua regia on this stuff. Start with some muriatic acid as usual, of course. Couple hundred milliliters of that. Now, I'm going to make a fairly strong aqua regia here. I'm going to make old school aqua regia. That's about 30% nitric acid rather than putting it in with the dropper like I normally do, just because platinum is reluctant to dissolve. So I'm going to hit this pretty hard and see how much of this stuff we can get to dissolve down here. I really don't think very much of it dissolved before in part 2, just enough to give me an indication on my stannous chloride test that there was some platinum there, but really, I don't really think we dissolved very much of it. So there's about 60 milliliters of nitric acid into about 200 milliliters of hydrochloric acid. So that's going to be some super strong aqua regia right there. Let me get the fume hood going. And I'm going to put some heat to this. So one nagging thing at the back of my brain that has me worried is that in part 2, I dissolved all the platinum out of this stuff that was there. And whatever this stuff is, isn't platinum. It's heavy. It's very heavy. Looks like a metal. But maybe it's not platinum. Maybe it's something else. But I don't know. Anyway, we'll see what happens once this heats up a little bit. See if we get any kind of reaction. We'll do another stannous chloride test. See if we're getting platinum in solution. And ultimately, we'll see how much of this stuff dissolves. Then once we've got it all dissolved, I'll combine the liquids from my 3 extractions, and we'll see if we can drop the platinum out of it and see just how much platinum we get. So, as usual, I'm going to let this cook for a while, see if anything happens. Well, it's been a few minutes, and the liquid's starting to warm up. We're starting to get some kind of reaction in there. I'll take that as a positive. Hopefully, that is platinum going into solution. It's only a few minutes later, and I have turned the heat way down. In fact, I'm going to turn it down a little more, because we've got a heck of a reaction going on in there. But that is some super strong aqua regia, so yeah, I am not surprised we've got that kind of a vigorous reaction going on. But I don't want it to get so vigorous that it boils over, so I've really killed the heat, dialed it back. But hopefully, we are actually dissolving platinum. Okay, it looks like it is calmed down a little bit, so I better keep an eye on it, even at this very low heat level. Let me turn it down a little more. But it does not look like it's going to boil over anymore, so I'm happy about that. So I'm just going to let it go and see how much of that black stuff on the bottom of the beaker disappears. Hopefully, most or all of it will. Alright, it's been about a half an hour, and this stuff is still going gangbusters in here. Now, I hope the stuff on the bottom is actually dissolving. The volume of it down there really doesn't look any reduced. It still looks like there's a lot of stuff on the bottom of that beaker. I hope it's not just down there acting like boiling stones for the aqua regia. I guess we'll find out. I'm just going to let it go. I'm not going to do anything to it. I'm just going to let it go. Maybe another hour and a half, 2 hours. And we'll see if the material in the bottom of the beaker starts looking reduced. Of course, if the reaction dies down, I might have to refortify the aqua regia. Alright, I moved this off of the hot plate onto the cool hot plate so it would quit boiling and fuming. So now I think it's cooled off enough I can get a stannous chloride test on it. A little bit on the spot plate here. Okay, we'll go over to the bench. And we'll do a stannous chloride test. So I'll give you a close-up look at it. See what we got here. I should be thinking positive. I know, but that's some pretty weak-looking stannous chloride. But the test will tell us for sure. Okay, as usual, some very fresh stannous chloride here. And hey, okay. That's, I guess, not too terrible. The stuff's not really dissolving, but apparently we do have some platinum in solution. I wonder if I just need to let it go longer. I could do that. You know what? Let me do that test again. Let me get another little bit. A little bit here. Okay. A little bit of stannous chloride. It's not really pink. Maybe a little bit pink around the edges. I was starting to wonder if maybe we got something besides platinum here, like maybe rhodium or something. But I don't know. It's not really looking like rhodium. It's looking like platinum. It's just not going into solution very fast. Either that or this is all of it that will go in solution. Maybe I got all the platinum. Tell you what we'll do. I'm going to put it back on the heat. I'm going to put a little fresh hydrochloric acid on it and some more fresh nitric acid on it, and we're going to let it go and see if we can actually get some of that stuff in solution. Okay, let me get this back onto the hot plate. I'm going to put some more muriatic acid on it. Probably boiled a lot of the HCl out of this. So another 200 milliliters of muriatic acid. And then let me measure out another 60 milliliters of nitric acid. You know what? It does look like maybe there's a little less of it on the bottom than there was. Okay. So, that's going to be a little bit more than 60 milliliters, more like 70, because that's the end of that bottle. I'm going to have to crack open another bottle of nitric acid. But I can do that. I've got plenty of nitric acid. I just found a new source of it that's reasonably inexpensive. I'll put a link to that in the upper right. You can check that out. I made a video about it. Let me get the heat turned back on here. Yeah. It looks like there is less. When I poured more acid in, it kind of stirred it around, and it's like, yeah, there's not that much on the bottom anymore. So maybe this is working. Okay. Let this get warm again, and see if we can get any more of that stuff in solution with some more of our super strong aqua regia here. Well, we've been going for maybe another half hour on the revitalized aqua regia here. It's hard to tell if we've actually dissolved anymore because it's all piled up around the edge. But maybe I'm just being impatient. That's a possibility. I tend towards impatience, so we'll just let it go. See what happens.
Several days later.
Alrighty, so we were about halfway through day 3 of boiling this stuff in there, and let me move the camera a little bit so you can see how much stuff is still on the bottom of the beaker. Whether anything is really still dissolving or not, I don't know. I mean, we're still making orange fumes, so something's going on in there. I have read that sometimes you need to refresh the hydrochloric acid in there when you're trying to dissolve platinum because the HCl in it gets used up. I've done that. I've refreshed the HCl. I've also added some extra nitric to it. And, well, I don't know if anything's really happening or not. So I think what I'm going to do is I'm going to let this go until I see no more orange fumes, and then I'm going to call it. And whatever's in solution is in solution. Whatever's not in solution, I'm going to say isn't going into solution. And yeah, we'll see. I've been having a thought about why there might be platinum in these things, and I could be way off base, but had a little thought. Platinum is used as a catalyst in the polymerization of a lot of plastics and rubbers. And I'm wondering if that's really what we're seeing. I don't know. Possibly. I can't think of any other reason why there would be platinum inside these things. But yeah, I'm starting to think that all that stuff on the bottom of that beaker is not platinum. It's just something else that's really resistant to aqua regia. But anyway, like I said, I'm going to let it go. And when the reaction looks like it's finally done, I'm going to call it. And we'll see if we can get platinum back out of solution enough to hopefully weigh. That would be great. Okay, after a little over 3 days of boiling, there's still a lot of solids on the bottom of that. And I renewed the hydrochloric acid and nitric acid a couple of times. Whatever it is not going into solution. Now, it looks like it's gotten really concentrated here compared to these, but I think it's just some leftover carbon that was in the liquid after the concentrated sulfuric acid, pyrrolization. And I think that's just gotten into solution with the extended boiling. So I really don't think it's that concentrated. But anyway, I've got the 3 liquids, this from part 2, this from my small scale test, and this from this video right here. So what I want to do today is get them filtered so that we can try and drop whatever platinum they contain. And we'll get a good look at what's on the bottom of this beaker after all this boiling too. So let me get started here. Yeah, my pump's quite loud right now. I think that's its death rattle. I think it's on its way out. They don't last too long putting the nasty vapors from this stuff through them, but I have a spare in case it clocks out on me, so I'm not too worried. Okay, there's the first one through. Here's my small scale test. This has actually been filtered pretty well already. So was the last one. But you know what? We'll just filter them one more time. And then this is the one that really needs the filtering. So get it filtered. Oh yeah, there's some particulates coming out. I can see it starting to plug the filter a little bit. It looks black. I'll bet it's carbon like I thought. Yeah, I don't think I got all the carbon off of this after the pyrolysis. The sulfuric acid. Well, there's still quite a bit of solid in there. It did not dissolve. Some of it's making its way into the filter here, but a lot of it's being right down here in this beaker. I guess the volume is down, so that's good. You watch the whatever it is out of this beaker, out of this filter, and I'll give you a look at this with my phone so you get a better idea what's left in the beaker. Yeah, so here's what's left in the beaker. So, yeah, I guess there is quite a bit less volume there. Here's what's caught on the filter. So some of that shiny stuff is in the filter. A lot of carbon too. But, well, I guess we'll find out what we dissolved out of this stuff. What's left in here just simply does not want to dissolve in aqua regia. Alright, so what's next for this stuff? Well, we're right at, well, just below a liter of liquid here. And I know it's probably not super concentrated with platinum. So I think what I want to do is evaporate it down to half or a third of its volume before I try to recover the platinum out of it. And I'm about to dilute it a little bit more here as I clean out this flask. So I think what I'm going to do is I'm going to put it on the hot plate in the fume hood and just evaporate it down slowly. Not going to boil it because I don't want it to spatter. Just slowly evaporate it down. And then we will move on to trying to recover the platinum. Alright, so let me get this in the fume hood and get it on some heat so we can start evaporating it down. Cover it to keep it clean until then. Alrighty, got it in the fume hood. Let me turn the heat up on it. Not high enough to boil it, but high enough to start evaporating it off. Take the lid off so that evaporation can happen. And you can't really see it, but I have the beaker with all of the undissolved solids and the filter that I just used in the back there. Just going to hold on to it for now, just in case, okay? Maybe there's, I don't know, Johnny's XRF did not show any rhodium or iridium or rhenium or anything like that. But I don't trust his XRF. This is a good time to take a look at it. Let me throw it up here on the screen and talk about it. This is the XRF I got from Johnny. And the reason I don't trust it is because it did not show very much copper and it didn't show any selenium. And that's what the bulk of the material in these things was, copper and selenium. Okay, so something went seriously wrong with his XRF there. And it showed a tremendous amount of platinum down here, which, no, there was not a tremendous amount of platinum. I think it was a thin coating on the surface of some of those plates that gave a false reading of there being a lot of platinum there. And, yeah, but I mean, we got some stuff in them that would not dissolve. So maybe it's not metal. Maybe it's some kind of ceramic or something, though I don't know why that would be in there either. But just in case it's some kind of, you know, really resistant platinum group metal like iridium or ruthenium or something like that, I'm going to keep it, okay? But for now. But yes, I don't trust this XRF. Something went seriously wrong with Johnny's XRF on this stuff. Anyway, we'll get this evaporated down. It may take a day or so. Let's see, we are just a hair over 1 liter with all that rinse water from cleaning out the flask. So I'll get down to maybe 400 milliliters, maybe a little lower. And we'll go from there. So I have evaporated this stuff down to just a hair below 400 milliliters. And I realized I'd forgotten a step at some point. So I need to denox this stuff. So I am adding a little bit of sulfamic acid powder directly to it here to try and destroy whatever nitric acid is left in here. I was very heavy-handed with the nitric acid trying to dissolve this stuff, so I have no doubt there's a lot of nitric left in here, and the sulfamic acid is giving me an affirmative reaction on that. I mean, I could evaporate it all the way down to a syrup, which is what Hope recommends in her book. But I'm thinking this might do the job too, without me having to take it all the way back down to a syrup and then rehydrate it. So we'll see. Anyway, yeah, I think I put a lot of nitric acid in this stuff. So I don't know. I might have to bite the bullet and either evaporate it down to a syrup or mix up a saturated solution of this stuff and add enough to denox it and then continue evaporating it back down. But we're right at about the amount of material I want to have here. I'm going to let that sit and do its thing for a little while and then add some more sulfamic acid to it and see if I still get a reaction. Hopefully I can destroy all the nitric this way. We'll see. Well, unfortunately I had to bite the bullet and mix up a saturated solution of sulfamic acid because I must have been really heavy-handed with the nitric. I mean, I know I mixed up some really rich aqua regia to try and get this platinum in solution. So yeah, there was a lot of excess nitric in there. So our level is back up almost to 600 milliliters, 500 and change. So I'm going to have to let this evaporate down some before we move on to trying to recover the platinum from it. But in the meantime, while that's going on, I'm going to mix up the solution I need to recover the platinum. So I'll show you that while we're waiting on this to evaporate down, and I'll turn the heat back up on it some, get it to evaporate a little quicker. So to get the platinum out of solution, I need a saturated solution of ammonium chloride over here. And that means I've dissolved as much liquid in the water as will dissolve in it. I'm using distilled water, by the way. So that's going to tell me that I've got as much ammonium chloride dissolved as I can. I need to put a little bit more in there because it's all disappearing. Ammonium chloride gets very cold when it dissolves in water. That's just why I've got so much condensation on here. But I'll put a little bit more in and keep stirring it, because I'm going to need a fair amount of this stuff because I need it to precipitate the platinum out of solution, and I also need saturated ammonium chloride solution to wash the platinum precipitate with so it doesn't go back into solution on me. So I'll get myself a nice saturated solution here. I think is enough liquid to do both jobs. And then we'll move to actually tackling the platinum solution and see if we can get the platinum back out. And this method is right out of C.M. Hoke's book too. So if you don't have a copy of her book, on refining precious metal wastes, you probably need to get one if you want to do this, okay? There'll be links down in the video description where you can get the book and all the other equipment and chemicals I'm using. Alright, let's see how this does. See if we're saturated yet. Alright, I have finally mixed up a saturated solution of ammonium chloride. It took a lot of ammonium chloride in only about a half a liter of water to get it saturated. Anyway, I have filled this little wash bottle with the solution, and I have this much of it left. So as soon as the liquid in the fume hood boils back down to a lower level, first we'll do a stannous chloride test on it and see how it looks. I'll bet it's pretty concentrated since I boiled it down so much. And then we'll see about recovering the platinum from it. See how much we get. Okay, I've got this stuff evaporated about back down to 400 milliliters, but I stopped evaporating it because we got to precipitate. What it is, I am not sure. It could just be sulfamic acid. That's quite possible. Oh, it looks kind of dark, so I'm not sure. So I've stopped evaporating it down. I suppose I should get a stannous chloride test on it to make sure all the platinum hasn't dropped out of solution, although I kind of doubt it. And then figure out where to go from here. Yeah, I'll bet that's just sulfamic acid in there that's come out of solution as I boiled this stuff back down. It doesn't move on the bottom of the beaker like metal. It moves like something very light, so hopefully our platinum is still in solution here. Let's have a look. Zoom in a little bit. Good focus. All right. Oh yeah. Oh yeah. The platinum is still there. All right, good. Looks much more concentrated than it was. Is there gold in there too? I don't know. Maybe it's just a very dark platinum stain. All right, so I think I probably need to filter this stuff before moving on to try and dropping the platinum, just to get whatever that precipitate is. Yeah, that's not metal. That's something else because it's not moving to the bottom of the beaker as I tilt it. It's probably just sulfamic acid that came back out of solution. All right, so I will give this a quick filtration. I'll probably just gravity filter it real quick, and then we'll get to dropping the platinum out of it. Yep, just giving it a quick gravity filtration here. It's coming through nice and clean. I will probably need to switch to vacuum filtration for recovering the platinum once I put the ammonium chloride in it. But for now, I'm just going to clean this stuff up before we get to recovering the platinum. I want this liquid as clean as possible before we do, so whatever precipitate we get is just platinum. All right, let's do this thing. Let's see if we can precipitate any platinum out of this now very clean solution again. So I've got my saturated solution of ammonium chloride here. And you know what? There's a whole lot of nothing happening. There should be something happening. We should be getting an orange precipitate. Okay. Well, we'll let it stand and see if anything happens, and I'll mix up some more ammonium chloride solution. But if that's really platinum in there, and we got a positive stannous chloride test for it, several actually, we should see an orange precipitate. What is it, ammonium hexachloroplatinate, I think it is. But we are getting focus. Huh. Okay, well, let me mix up a little bit more of this stuff and see if we can get anything to happen. All right, we'll try this one more time. This is not looking promising. Oh my goodness. So where have I gone wrong? Is there actually any platinum in there? Could there be something in these blue blobs that fools both an XRF machine and a stannous chloride test into thinking there's platinum in it when there isn't? I don't know. Leave a comment. Let me know what you think. Let me know if I'm doing something wrong here. If that liquid was full of platinum, there should be an orange precipitate that's formed. We are not getting one. Curiouser and curiouser. Okay, let me give this a think. All right, it's the next morning. I was kind of hoping something would happen overnight with this, but it didn't. Off camera, I have tried a couple of things. I thought that maybe the pH on this had gotten too high for the reaction to work. So I added some uriatic acid to it, but that made no difference. I also thought maybe it was too cold for the reaction to work. So I heated it up. That made no difference. We have no reaction. I reread the chapter in Hoke's book on recovering platinum from solution. And I did everything right, according to her. If there was platinum in this stuff, it should have dropped out as an orange precipitate. Nothing happened. Okay. So I'm coming to the reluctant but inevitable conclusion that there really isn't any platinum in this stuff. And we've just been chasing a ghost. Johnny and I both. For two different reasons, I think. Um, Johnny thought there was platinum in this stuff because of the XRF results, which I'll put back up on the screen. According to the XRF, there should be a whole lot of platinum in these things. But I knew from day one that there wasn't. Certainly not anything like what the XRF is saying. That high a percentage, no way. And then I also knew that the XRF was wrong in other ways because they were loaded with copper, and copper is not showing up as a very high percentage at all. And they were loaded with selenium, and there's no mention of selenium at all in the XRF. So the XRF was bad, and I think I know why. I did some research on XRF and how it can give you false positives for precious metals. Basically, if you have an XRF machine and you don't know what you're doing with it, you put it in precious metals mode and you measure base metals, which is what I think we had in this stuff, nothing but base metals. It will tell you there are precious metals there, even if there aren't. And it will give you really anomalously high readings for non-existent precious metals. So I think the guy who did the XRF for Johnny had his XRF machine in the wrong mode, and it told Johnny that there were a bunch of precious metals in there when there weren't any at all. Okay? So, if you were to put the XRF into electronic scrap mode, it probably would have given a much more accurate indication of what was in those things. It would have probably shown the selenium, the copper, other stuff. But it was in precious metals mode. And you can tell because, look, the precious metals are the first ones on the list. If it had been in electronic scrap mode, things like copper and other stuff would have been higher on the list. So, yeah. Okay, so his XRF was done wrong, in the wrong mode. So that doesn't explain, though, why I keep getting, an indication for platinum when I do a stannous chloride test. Look, it's still there. It's still orange. It's still orange. So what is causing me to get a false positive for platinum if there's no platinum in this? Well, again, I did some research. I was very busy on the computer last night, and the Google servers were overheating with all my search requests, let me tell you. So it's possible to get a false positive for platinum if there's cobalt and or nickel in your solution. As far as I can tell. I mean, it's kind of anecdotal. I don't have that much experience dealing with platinum, but I see other people online saying, yeah, cobalt and nickel will give you a false positive for platinum if you do a stannous chloride test for it. And I have to admit, the color is right, but the texture is not. But again, I don't have that much experience dealing with platinum. The stuff sort of, agglomerates together into a bunch of little particles, which then settle to the bottom. which I'm not used to seeing. Certainly with gold and palladium, it doesn't do that. See, now the color's changing because all the particles are settling to the bottom over time. So I don't think it's really platinum. I think it's false positive because we probably got cobalt and nickel in here. And I can believe there's cobalt and nickel in here, even though the XRF didn't show it, because those would be common components in selenium rectifiers. And we didn't know until the middle of episode 2 that that's what I was dealing with selenium rectifiers. So yeah, platinum is not used in selenium rectifiers, so I've been questioning from the very beginning why there would even be platinum in them, or any platinum group metal, or any precious metal at all. There's no gold, there's no silver, there's no platinum, palladium, rhodium, iridium, any of that stuff in selenium rectifiers. And by the middle of episode 2, we knew we were dealing with selenium rectifiers. So, yeah. So it's just a case of two different false positives. One with Johnny's XRF, and the second one with my stannous chloride tests. So for 3 episodes now, we've been chasing a ghost. There is no platinum in these things. Sorry, Johnny. You know, I know you've gone to a lot of trouble to harvest these things and hoard them, and I've gone to a lot of trouble to process them trying to find the platinum, but there is no platinum in them. What is this stuff that won't dissolve? I don't know. It could be some sort of crazy metal oxide that was produced with the nitric acid treatments, quite possibly. I don't know. But it's not platinum. It's not iridium. It's not rhodium. Don't know what it is. Anyway, if you've watched all 3 of these episodes to get to this point of epic failure, thanks for watching. And like I've always said, if nothing else, I can always serve as a bad example for others. All right? We can't always assume what other people are telling us is the truth, and we can't always assume what our own tests are telling us is the truth. So, yeah, that's the lesson we take from this. Sometimes everything's going to line up to fool us and make us chase our own tails for a while and waste a lot of time and chemicals for nothing. Now, I am going to keep this stuff for now because some of what I'm telling you is speculation. All right? Some of what I'm telling you is clearly speculation. What I might do is evaporate this down to a solid and keep the solids. And I'll keep this stuff. And I might want to run some more analytical tests on it down the road when I get some time. And when I figure out, you know, definitive tests for cobalt, nickel, whatever. And make sure that's actually what's going on. So in the future, if I'm chasing some hard to recover precious metal, I can run these same tests in the future to make sure I'm not just chasing a ghost again. And if I get any results from this, I'll make another video for the rest of you folks out there. So, you know, you'll have those same analytic testing methods under your belt so that you don't wind up chasing ghosts too. I'm going to wrap all this stuff up, clean up my bench, and go back to doing something I know how to do, like recover gold. So that's going to be in the next episode, I think. All right, well, thanks for watching this series, even though we ended in epic failure. If you enjoyed it, learned anything from it, and, you know, had fun laughing at me, whatever, give it a like, give it a thumbs up, and subscribe to see my future episodes where I think there will actually be precious metals in the end. And I'll see you in those future videos. Thanks a lot for watching this one. Bye.